Hello, today is the last day of Chapter 7, 7.6, which is solving systems of linear inequalities. So just like we solved systems of equations, meaning we graphed one line and then we graphed the other line, wherever they crossed, that was our answer. Now we're going to have to do that with inequalities, meaning we're shading one graph above or below and we're shading the other graph above and below. Wherever they both are overlapping will be our answer. So instead of just the point wherever they touch, it's wherever the graphs, the inequalities, are going to be overlapping. So we need to solve for y in order to graph so that both equations are in the form y equals mx plus b. So if I look at these first two, these ones are already solved for y, so we can graph them on our coordinate plane. So this first one begins at -2. And we have a slope of -1, or as a fraction, -1/1. So -1 is down 1, and 1 to the right. Down 1, and 1 to the right. Or the opposite would be up 1 and 1 to the left. So there's that line. Reminder that if we have less than or equal to or greater than or equal to, that's going to be a solid line. If we have just less than or greater than, it would be a dashed line. So this first one up here is dashed, so go ahead and draw some dashes through there. And then we need to determine, are we shading above or below this line? So this one is the symbol greater than. Reminder, greater is going to shade above. And then, like an L, less than, we will shade below the line. So because this is greater, I'm going to shade above. So I'm not going to shade the whole thing right now. I'm just going to put some arrows on it, so that I would shade the whole top half. And then I'm going to graph the other line. The reason I'm waiting to shade is because it's going to be hard to graph this line if half of the graph is colored in. So this one, in the form y equals mx plus b, b is 6. So we're going to start it up 1, 2, 3, 4, 5, 6. And our slope is 3, or 3/1. So rise 3 and 1 to the right, or down 3, 1 to the left. Down 3, 1 to the left. And this one has the equal to right here. So this is not a dashed line, it is a solid line. So go ahead and draw your line through this one. And then determine which way we are shading. This one has an L for less than, so we would be shading below the line here. Now our answer is going to be whichever of the 4 parts. You notice how we cut this into 4 pieces. It'd be like chunk 1, piece 2, piece 3, and piece 4 here. We need to shade in one of these depending on where all of our arrows are pointing. So you can see that in this area 4, the red arrows and the blue arrows are both pointing in that direction. Because if you shaded both, if you want to shade both, you can. For example, if I shade this one above, the red one above, and then blue is below, well, they overlap in this section here. I know that's really difficult to see. I'm going to use a different color to see if it'll be easier for you to see where it's shaded. So I'm going to shade this blue one would be below the line, everything below the line. And the red one was everything above. I'm just going to use yellow, everything above this red line. So now that's easier to see. Where it turned green was where both were overlapping. So that would be our shaded answer. So let's try the next one. This first one is already solved for y. So we're going to begin at -2 on our y-axis. And our slope is 1, or rise 1, run 1 as a fraction. Up and right, up and right. the opposite, down and left. This graph, or this inequality, has the equal to, so it's a solid line. So draw your line through there. And then, like an L, less than would be shading below the line. Our second equation is not solved for y. It has a negative 1 in front there. So we need to get rid of that negative 1 by dividing by negative 1. However, be careful, whenever you multiply or divide by a negative, our symbol flips. So I'm going to rewrite this. We're really going to have y, flip your symbol, and then two negatives here make a positive 2x, and then 4 divided by negative 1 is negative 4. Yep, those two negatives made a positive. Good. So we're going to begin this one at negative 4. 1, 2, 3, 4 right here. And our slope is 2 over 1. So rise 2, 1 to the right. Up 2, 1 to the right. 1, 2, 1, 2. Or down to 1 to the left. This one does not have the equal to, so this is a dashed line. So put some dashes through here. And then because we flipped our symbol, we now have a greater than, which would be above the line. Oops, above this way. Now this one is a little tricky because you need to figure out where are both lines, or where are they overlapping. If you look at this section over here, well, the red line's pointing that way, but the black one is not. If I look here, nothing's pointing to that section, they're both pointing away. If I look to this top whole section, the black line is pointing that way, but the red one's not. So our answer is going to be down here, where the red's pointing down and the black is pointing up. So our answer is going to be right here in this little sliver where they're overlapping. So this shows the difference. You can color in with maybe two different colors to figure out where do they overlap, or look, where do both arrows point. I could also see back here that these arrows were pointing to that section and these arrows were. So now we have the same thing, but we just have 3 lines. This first one is already solved for y, so let's go ahead and graph it. We are beginning at positive 2, and our slope is negative 1 over 1. So down and right, negative is down, and to the right, or up and left. This inequality has the equal to, so this is going to be a solid line. And then this symbol, it does not make an L for less than, it's greater. So we're going to shade above that line, moving up. I'm just going to put a few arrows on there right now. Then I need to shade or graph this equation. Reminder, easy way to do this is going to say we are going to cross the y-axis at 4. So here's our y-axis. We're crossing at 1, 2, 3, 4 right here. If we're going to cross through this y-axis, we have to go horizontally right through at 4. And this does not have the equal to, so this is going to be a dashed line. And then this has an L for less than, so we would be shading below this line. So right now, you can see that both arrows are pointing to this section down over here, this triangle. However, we have one more equation to graph. So let's take a look at this one. X is less than 3. So we're going to cross the x-axis at 3. So here's x, here's 1, 2, 3. we're going to go through 3, we have to go vertically up and down. And down here. Again, this symbol does not have the equal to, so this is a dashed line. And it says x is less than 3. So we're looking at our x-axis, because we can't go above or below. We're now going left to right. Less than 3 here. It's not 4 or 5, it would be 1 or 2. So this one would be pointing to the left. Less than here would be to the left. So if you look at our graph, we need to figure out where are all 3 arrows pointing to. Now before we thought this section, which looks good, the red and the blue are pointing there, but the green is pointing away from that section. So we're close. The only section where all 3 arrows are pointing happens to be in the middle of this triangle area. The blue is pointing up, the red is pointing down, and the green is pointing to the left. So this section is what you would color in, or you can use 3 different colors and see where they overlap. Some of them look close, like for example here we have blue and green but not red, here we have red and green but not blue, and here we have red and blue but not green. So these 3 were close, but this is really where they overlapped. I would like for you to try this one on your own and then click play to see if you get it right. We have y is greater than negative x. It's really a negative 1x, and this is really in the form y equals mx plus b, meaning b is really just 0. So our slope is negative 1, or negative 1 over 1. So negative 1 is down, and then positive to the right. Down and right. Or up and left. This equation, or inequality, does not have the equal to, so that means it's a dashed line. Remember, these are dashed, and these are solid. So do some dashes through there. And then this does not make an L for less than. It instead makes greater than, which would be shading above. And then I'm going to shade this, or graph this next one. This one is also in the form y equals mx plus b. So b is negative 4. 1, 2, 3, 4. And our slope is 1 over 1. Up and right, up and right. Or down and left, down and left. This one is a solid line though, because we have the equal to. So draw your line through there. And then this is also greater than or equal to. So greater than is also above. So far, you can kind of see where both arrows are pointing. Right now, don't color this in, but right now they're pointing to this section, and that's where we would have to shade. However, we have one more line to graph. So this last one, we are going to cross the y-axis at 5. So here's y, here's 1, 2, 3, 4, 5. We're crossing, we're going through from left to right. And this way. So this does not have the equal to, so this is also a dashed line. And then we need to shade like an L less than, which would be below this line. So which section are all 3 arrows pointing to? Well, this middle piece, the green's pointing down, the blue's pointing up, and the red is pointing up. So they're all pointing to this section here in the middle. Even down here, where it forms that nice triangle. It won't always be the triangle shape. These two, it just happened to be that way. Here's a problem, I believe, looks similar to one that might be on your homework. It says chores. You need at least 4 hours to do your chores, which is cleaning out the garage and weeding the flower beds around your house. It is currently 1:30 p.m. on Sunday, and your friend wants you to go to the movies at 7 p.m. How much time do you have between now, which is 1:30, and 7 p.m. to do your chores? Well, if you think about it, if it's 1:30 right now, and we have to get to 7 o'clock p.m., well, from 1:30 to 2 o'clock would be 30 minutes. And then from 2 to 7, the difference between those, if we just count, would be 5 hours. From 2 to 3 would be 1, from 3 to 4 would be 1, from 4 to 5, 5 to 6, and 6 to 7. Each one of those would be an hour. If it helps to look at a number line, 1:30, then 2, 3, 4, 5, 6, 7. We have 1, 2, 3, 4, 5.5 hours. So you can write 5 hours and 30 minutes, or 30 minutes in terms of hours would be 5.5 hours. So now it says, let X represent the number of hours spent cleaning out the garage, and let Y represent the number of hours spent on weeding the flower beds. That's also what it says down here for X and Y. So it says, write and graph a system of linear inequalities, system meaning more than one, that shows the number of hours you can work on each chore if you go to the movies. So we know that we have less than or equal to 5.5 hours to spend on chores. So it says we also need at least 4 hours. So we need between 4 hours and 5.5 hours. So our chores are cleaning out the garage and weeding the flower beds. So they told us X is number of hours in the garage and Y is number of hours on the flower beds. So X plus Y, the number of hours here plus the number of hours here, has to be less than or equal to 5.5. Well, in the same situation, the cleaning out the garage and weeding the flower beds has to be at least 4 hours, because it takes at least that much time to do it. So we have to have greater than 4 hours. We could, it doesn't say 4 hours or equal to, so this would be a dashed line. We could spend exactly 5.5 hours, because that would be the cutoff right before we have to go to our movie. So we need to now graph this system. In order to graph, we have to solve for Y. So I'm going to solve these for Y. I'm going to subtract X or subtract 1X. So we get Y is greater than negative 1X plus 4. And if I solve this one for Y by subtracting 1X, I get Y is less than or equal to negative 1X plus 5.5. So I'm going to graph this one in blue. We're beginning at 4. And our slope is negative 1 over 1. So down 1, and to the right, down 1, to the right. This would be a dashed line because there's no equal to here. And then it's not like an L for less than, greater than. So I'm just going to put some tiny arrows on here. So this is a small graph. We'd have to spend greater than 4 hours there, so we'd spend more time. Any of the combinations up here would be more time than what we need. And if we graph this second one here, we're beginning at 5.5 or 5.5. And our slope is also down 1 and 1 to the right. So down to 4.5, 1 to the right. Down to 3.5, 1 to the right. 2.5 to the right. This one has a solid line. And has the less than symbol, so this one would be shading below the line. So you can see both arrows, I'm just going to color it in now, are pointing between this little area here. So the amount of time we spend on our chores has to be greater than this line, but less than this line in order for us to go to the movies. So it says identify 2 possible combinations of time you can spend on each chore. So you need to pick 2 dots that are within this shaded area. If I pick this point right here, that would be 2 hours, if you go down here, 2 hours cleaning, which is X, and over this way, 3 hours weeding, so 2, 3. You can pick any other points in here as well. You could spend 1 hour cleaning and 4 hours weeding. There are a bunch of other combinations you could list as well. You can, yes, you can list on this line, but you cannot on this line because this was a dashed line and this top one was solid. So next, a little bit easier, there's no y equals mx plus b. Here's just 2 lines again, crossing the y-axis at 10. Well, here's y, and 10 happens to be at the top. So crossing meaning going right through, right at the top there. Hopefully we don't have a greater than symbol because we can't go any higher than this. This has equal to, so I'm going to draw my line through. And yep, it says less than, so less than would be shading below. So right now it's really the whole graph. But then it says y is also, we're going to cross the y-axis at 6. 1, 2, 3, 4, 5, 6. This one also has the equal to symbol. So that tells us we're going to have a solid line. And then instead of less than, this one has greater than, so it would be shaded above the line. This is a very similar example to the one we just did with the words. So our answer would be between these 2 lines. This next one is already solved for y here, but the second one is not. So I'm going to graph this one first. Y, we're going to cross the y-axis at -2, so -1, -2. We'll go right through there. Remember, cross means we're going through the y-axis. Notice we didn't touch the x-axis. This one has the equal to, so again, solid line. And our symbol, it's not like an L for less than, it must be greater, which means we're shading above that line. Our second line we need to solve to get y by itself, so I'm going to go ahead and solve for y. Move our x's over first by subtracting 2x. So we have 3y is greater than -2x and a -6. And then divide everything by 3 to get rid of that 3. We have y is greater than -2/3 x minus 6 divided by 3, which is 2. So this one begins at -2, same spot, but our slope is -2 or down 2, 3 to the right. Down 2, 3 to the right, or up 2, 3 to the left, up 2, 3 to the left. And this one does not have an equal to, so it's not a solid, it's a dashed line. So draw some dashes through there. And it says we are looking for a greater than symbol here as well, so greater than would be above this line. So where do both lines point to? This one, the red one does, but not blue. This one blue, but not red. This section down here, nothing points to. So it must be this part up here. So everything above here, all the way in here, this whole part, and this whole part. The blue and the red are both pointing to this section. Again, if you're not sure, you can use two different colors to help you out. For example, if I colored above the red here, above red I'm coloring in one color. If I colored in blue above, that would be above the blue. Where they cross would be our answer, which is in green, which we just colored in the same way. Your answer would not include this section or this section because there's only one of the two colors there. They don't overlap. Alright, this last one we're going to do really quick. It says we're going to cross the y-axis at -1. The reason we're doing so many of these is because we're only doing one day of this lesson. Crossing at -1. If you don't want to put all the dots there, that's fine. We can tell it's going to go all the way from one side to the other. And we know, because of this equal to here, it's going to be a solid line. And this symbol is not less than, it's greater than, so we'd be shading above this line. It also says we're crossing the x-axis at -2. So here's x, -1 would be here, -2 would be right here. So we're going to cross or go through at -2. This graph does not have the equal to, so it's a dashed line. And then this also has greater than. So think here, this was -2. Are we greater at -1, 0, 1 to the right, or is greater than the -3s and -4s? Well, greater than -2 would be towards the positive numbers, so this would be shading to the right. And then our third graph, we need to solve for y. So I'm going to move this 1x to the other side by subtracting 1x. We get 2y is less than or equal to -1x plus 4. And then divide everything by 2. We get y is less than or equal to, well, -1/2 x. You can't simplify that. And 4 divided by 2 is 2. So we're going to begin at +2 on our y-axis right here. And our slope is down 1, 2 to the right. Down 1, 2 to the right. Now this is why we don't shade right away, because it's really hard to see where to put your points if you've shaded already. This one has equal to, so it's a solid line. And again, had this been a greater than symbol, we'd be shading this upper section. But since it's a less than, we're going to shade below this green line. And the only part where all three lines overlap is right here in the middle. Again, it just so happened based on which way our symbols are pointing, it could have been any of these other sections. Like this one's really close. Had the symbol for the red line been the other way, we'd be shading over here. Okay? Same thing here. If the blue line was shading or pointing the other way, we'd shade here. If the green line was pointing the other way, we'd shade here. But since they're all pointing towards the middle, this triangle is where our solutions are. Our last graphs, you need to write the system. So it's already graphed for you. You just need to come up with the lines that are graphed. Now, easiest way to do this is to figure out where your x and your y-axis are, because you don't need to write equations for those lines unless that is a barrier. For example, on this one, the y-axis is shaded to the right from here. So let's take a look. I'm going to look at this line here that goes left to right. We're crossing through the y-axis at 3. So we're crossing y at 3. I know that that's a solid line, so it has equal to, and that line is shaded above. So above would be greater than. So that line right here that we took care of is y is greater than 3. We also need an equation for the second line. Now this one crosses the y-axis at up 1. So in the form y equals mx plus b, because it's an angled line, we begin at 1. And pick 2 points to find your slope. Our slope is rise 2 and 1 to the right. So our slope m is 2 over 1, or just 2. So we have y is something then 2x plus 1. This line is shaded above as well, and they both overlap right where that shaded region is. So greater than, again, is opening to the left. There's no equal to because this was a dashed line and not a solid line. So these would be your 2 answers. This second one gets a little tricky because the x and the y-axis are actually 2 barrier lines. They constrain or hold in this shaded area. So there's one line here that they shaded above, that one. There's one line here that was shaded below. And then there was also a third line on the y-axis shaded to the right. Now, those ones that are on the y-axis and the x-axis, those are a little bit confusing. For example, this one's on the x-axis, but is really crossing through y at 0. So this one's crossing y at 0. It's going through the y-axis at 0. This red line is. And it's a solid line, so there's the equal to, and we shaded above that line. So y is greater than 0. And you can see that, well, on the y-axis, did we shade greater than 0? Well, yeah, we did. We shaded up. This green one cuts through the x-axis also at 0. It's a solid line there, so it's equal to, but to the right, instead of here at 0, instead of less than to the negatives to the left, we have positives to the right. So we're greater than or equal to 0 here as well. So meaning everything's in this positive side so far, the red and the green. But then we have this blue line, which is diagonal. So it means it's in the form y equals mx plus b. So this blue line begins at up 1, 2. And our slope from point to point is just up 1 and right 1, up 1, right 1, up 1, right 1, or 1 over 1, or just 1. This was also a solid line, so it has the equal to, but it's shaded below the line. So like an L, less than. So that one actually had 3 lines to use. This last set, the y-axis right here, we don't have any barriers there. Here's our x-axis, no barriers there, meaning it's constrained right at the x-axis. We just have these 2 lines. This line here, that we need to write an equation for, and this line here, this dashed line. Notice this one is shaded above the blue one, and this red line would be shaded to the left. So I'm going to do this red one first. It's cutting through the x-axis at 1, 2, 3. It's a solid line, so equal to, and we're shading towards 2 and 1, which is less than 3. The second line in the form y equals mx plus b begins at negative 1 on our y-axis. And our slope, if we find another nice point, oh, maybe right here, we're going up 1, 2, and over 1, 2, 3. So our equation would be y is something then 2/3 x minus 1. So we shaded above the line. This one was dashed, so there's no equal to. We shaded above, so that's greater than. If you have questions on these ones, please make sure to ask. However, your warm-up tomorrow will be a couple questions just like this. Your homework is out of the book, and you do need graph paper because we were graphing today.